Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of the forces and fields, which is like the topic which we already do in the previous lesson. This is the second part of that. So which is when we do the charged particle parallel to the electric field. Now we're doing the charged particle initially moving perpendicular to the electric field. They initially the perpendicular to electric field. After that, what happened? You have to find that. So we use the same types of thing, but now we will do the projectile motion to in this. Like not the projectile motion like directly in this, but we use the accelerated motion, uniform motion in this to find it out. So what they are we discussed today. So first we have to know that how can we go with that questions when we get. So when a charged particle is usually moving to a particular to the electric field, it will be described with the two types of motion. So we have a two types of motion as I told you. That first one is a uniform motion, which is of physics principle 0. So this is your physics principle 0 and direction to a particular to a direction to the field. Then the accelerated motion in the direction of the field. And this is your physics principle 1. So that's the two principles we use, and sometimes they mention the question that identify that two principal bases. So always the 0 and 1. So as we know that uniform motion is one direction, and accelerating motion in the direction compared to uniform motion is called the projectile motion. So when the uniform motion is the one direction and accelerating motion in the direction that perpendicular to uniform motion, we get the projectile motion, which we do in the grade 11 physics, very like full unit we do. So as the charged particle usually enters by to an electric field will undergo a projectile motion. So that's the all the thing when the charged particle usually enters a particular field to an electric field, we will do the projectile motion in that. We will examine the case where the particle enters directly perpendicular to the field and allows us to treat it like the horizontally launched projectile. So we do projectile, electric field, accelerated motion all in the one topic. So how does this happen? We're basically doing the horizontally launched projectiles, and in the case of uniform motion and in case of accelerated motion, which is the anti-parallel to the electric field. So first one, we have to do the particular electric field, which is uniform motion. When it's uniform motion, so we use a direct formula, which is the V is equal to delta D upon time. This all should be now perpendicular. Where your this velocity should be constant and does not change anything. So that formula you use when you have a uniform motion and it's directly perpendicular to electric field. But when we have a uniformly accelerated motion which is anti-parallel to the electric field, like in this, so when we use this thing, so in that case your Vi which is parallel is 0. And when we use that distance formula, which is the kinematic equation, so from here when you have this thing plus half a parallel d. So this thing comes to 0 directly when we use that. So this comes to directly 0 and your delta d, which is parallel, is equal to half acceleration parallel and d. You use directly this formula. Some things are like very confusing in this, but when we do on the question and we straight to the question, you will understand that how this works. So which do you understand with this example I'm sure. This is like of the sometimes big questions you get. Questions are big, then answers sometimes also big. So but we will do like you have to know. So one thing more which we do in the particle like which is in the previous topic like that MA is equal to Q electric field. So this thing we also use. In that case, our net force is equal to electric force. This thing we have to use. Basically that uniform accelerated motion. So let's move on to example. So we have the diagram over there. So two horizontal plates are separated by a distance of 5.0 centimeter. A bead of electrons is directed horizontally into the region between the plates. So this is the bead of particle. It goes like this. So the path of the bead is deflecting as shown below. Electrons in the bead have a speed of 9.0 into 10 raised to 1 centimeter per second. They enter the region between the parallel plates. The electric field strength in the region between the parallel plates is 3.10 10 per 3 Newton coulombs. We have to identify the two physical principles used in this. And we also find, they mentioned, we find the horizontal distance. We have to find this horizontal bilateral in the mean in the which between the parallel plates. So horizontal distance means, so in that case, I mentioned that this is your x direction, this is your y direction in all times. So what you have to find in horizontal, this one, so horizontal distance means the x-axis, so you have to find the delta dx. You have to find in the uniform motion part. So for this type of motion, you have to make some table of this. So x, which is uniform motion, and the y, which is your accelerated motion. So in that case, in this part, you have to find this one, delta dx. Your vs is given to us, which is this one, 9.0 into 10 raised to power 6 meter per second. At that speed, they go into this. So that you have. Next thing, your time is not given to us. You have to find that time. That dy. You have that dy. So it goes over there and we want for horizontal distance at that point. So this means that from here to here, this is your delta dy. And this have to find, which is delta dx. So the from here to here is the same as the from here to here. So we say from here to here, so this is like 2.0 centimeter, which is we want in meters. So you get like 0.020 meters. And as I told you, in that case, your initial one, in accelerated one, is remain 0 all the time. Time you have to find. Electric field you have in that case. So electric field is given to us. So which is 3.10 10 raised to power 3 Newton coulomb. Always electric field goes to accelerated motion, not in the uniform motion. For that all kind of work when we do, we want one thing also in this, which is acceleration. And you know that from where you get the acceleration is with that formula. So the formula you have to firstly use. So let's find the acceleration first with that information we have. So F net is equal to Fe. Then F net is Fa is equal to Q electric field. You have to find that acceleration, which is Q into electric field divided by mass. So that Q is 1.60 10 raised to minus 90 because we consider this is the electron. So this is the beam of electron. So the electron charge, electron mass have been used in this. And the electric field is given to us, which is 3.10 10 raised to power 3 Newton coulombs. Divided by mass is 9.1 by 10 raised to power minus 31 kgs. So when you find this, you get about the acceleration of 5.4445 is equal to this into 10 raised to power 14 meter per second square. So this is the acceleration. And why you find the acceleration? Because of the time you have to find. So you have to find the time now. So for the time you have that one formula, which is delta dy is equal to vi t plus half a y t square. This is also so that vi is 0. So initial is always 0. So it comes 0. And your dy now is equal to half ay t square. We have to find the t. So t is equal to that half goes over there like this, divided by acceleration y, and this goes like that. So square goes like root. So dy you have 0.020 meters. Ay you have to find, you find already. So 5.445, that is to 14 meter per second square. This goes like this. At the time when you calculate this and you go square root of this, you get 8.5713 is equal to into 10 raised to power minus 9 seconds. So this is your time. Now you have the time, and that time is always equal to this also. And from time you have Vx you have, so you can find the dx. So your Vx is equal to delta dx upon time. So that delta dx is equal to vx times t. So delta dx is equal to vx, you have 9.00 10 raised to power 6 meter per second. Time you already find, which is 8.5713 to 10 raised to power minus 9 seconds. And when you find this, you get about 0.07714 meters. You started from centimeter because you already think you have in centimeters, so you have to left the question answer in centimeters. So you do just multiply this with 100. Just multiply this by 100 centimeter, which is equal to 1 meter. Meter cancel out, and you get your horizontal distance 7.714 centimeters, which is equal to 7.71 centimeter. So that's how you can find your that much one. And what's the physics principle you use? So firstly you use, in that case, in this type of thing, you use the physics principle 0, which is a uniform motion. And when we do this time method, you use the physics principle 1, accelerated motion. So you use 0 and 1. This you have to measure. Sometimes you get this question 0 and 1 in numeric response. So that's how work you have to show to do this type of question. This is an easy question somewhat, but lots of work going on. You have to be careful when you're doing the values. Sometimes this is goes up, sometimes it goes down. When you practice questions, we do that question. So that's all what you have to do when you do that corrective questions. So that's all for this lesson. We do only one topic in this. So this is like you have to do practice in this and you get the questions in. So now we'll have to do only one topic of the electric fields, which is the minus spiral or dropper spiral we do. So important topic, and we'll do the next lesson. Then we'll start with the magnetism too, which is again the last part of this unit. So learning myself with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, like me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.